All right, the nth term test for convergence is our first test. It turns out it's not actually a test for convergence, it's a test for divergence. So the basic idea here is that you can figure out if something diverges just by looking at the limit as the terms approach infinity. I kind of mentioned this quite a bit in the intro video before this, so I'm going to blow through this pretty fast. But the basic idea is that if you list out the terms to a sequence or to a series, they better be getting smaller. They better be approaching zero. Otherwise, there's no chance that the thing converges, or, in other words, adds up to a number smaller than infinity. So unfortunately, this test won't tell us if something converges. It can only tell us if things diverge. It can kind of rule them out from converging. So if you write it down, this is the technical, statement of the theorem. But if the limit as x approaches infinity, or I guess as n approaches infinity, of the a sub n is just the nth term, because as you list out a series, it's like the first term plus the second term plus the third term, and the terms are just called a, and a sub n would be like the nth or the elite term. So if we're not approaching, as n approaches infinity, if the infinitieth term is not pretty close to zero, then the series diverges. So now we've got that out of the way. Here's a few that converge. I actually used the same list in the intro video because it's so common. But this one right here, it does happen to converge. It converges to 2. So if you keep adding this up, it'll get really close to 2. You add these all up, they'll approach 0.111, repeating, because each one of these terms just adds one more 1 after the decimal place. And this one's approaching 0.25, repeating. Just keeps going, 25, 25, 25 forever. So these converge, and you can see that they all do have terms that are getting much smaller. But the harmonic series, I've mentioned before and I'll mention again, this is one that looks like it should converge, but it doesn't. And you can prove this with some of the later tests we'll learn. But the harmonic series is the one where 1 over n is the formula for the terms. So you get 1 over 1. So it's really like 1 over 1 was the first term because n equals 1. So 1 plus 1/2 plus 1/3 plus 1/4. This thing diverges. You can see it satisfies the theorem. So the theorem said that a sub n, basically, if it's not equal to 0, the thing diverges. But for this one, the limit is 0. So these terms are getting smaller and smaller, and yet it diverges. So that's why it's important not to think of this as a test for convergence. It's just going to help you rule out stuff that will diverge. All right, so here's a straightforward one. The instructions might have said something like, use the nth term test to test for divergence or something. So all we need to do is just figure out, hey, what's the limit as n approaches infinity of a sub n? Well, I don't know. So we want to take the limit as n approaches infinity of 1 over 3 to the n. So there's two ways to do this. One is to sort of use your limit stuff and say, oh yeah, if we plugged in infinity for n, we'd get 1 over a ridiculously huge number, which is 0. Another way to do it is to list out your terms. So you could actually rewrite this, not that you have to, but I just want to point out when we see a geometric series, and this is a geometric series. This is 1/3 to the n. So each time you add 1 to n, you get a higher power 3. So the first term will be 1/3, the next will be 1/9. And this is a good strategy whenever you're stuck, is just to list out the terms and see what happens. So what we're getting here is all the powers of 3. And you can see they're definitely getting smaller. But technically, this is a geometric series because to get from each term to the next, we're multiplying by 1/3. So good to keep an eye out for that, just because when that happens, you can actually find what the sum is. So we didn't ask it in this question, but just to remind you, and we'll go over this more in the next video about geometric series, the sum of a geometric series is going to be the first term divided by 1 minus r. So in this case, the first term is 1/3 over 1 minus r. R is just the number that you're multiplying by, so it'd be 1/3 in this case. So you get 1/3 over 2/3. Those cancel, and we get 1/2. So kind of cool that 1 over 3 to the n adds up to 1/2 after infinity terms. But you can see the terms are getting a lot smaller, very small fractions, so it kind of makes sense that it's not a big number. Anyway, so that's an obvious example of where the nth term test failed because it didn't make this thing diverge. But because we recognize it's a geometric series, we might notice that it converges. All right, here's a couple just to show you what the nth term test is all about. So 1/3 of the n we just did. We know that converges because it fails the divergence test. So does 1/3 of the n diverge? No, it doesn't, because the limit as n approaches infinity of a sub n equals 0. So it's not equal to 0, which means it doesn't diverge. So 4/3 to the n though. So this is another geometric series, except because r is bigger than 1, each term is going to be 4/3 bigger than the previous term. We're multiplying by a number bigger than 1, which means this, on this one, the limit as n approaches infinity is equal to infinity. Because if you raise 4/3 to a really high power, you get infinity. So this diverges by the nth root test, or sorry, the nth term test. And then 49/50ths, because it's a fraction less than 1, that means the ratio is less than 1, so the limit as n approaches infinity is going to actually be 0. Because even though 49/50ths it's like 0.98, so it's it's pretty close to 1. But if you raise 0.98 to a really big exponent, like 1,000 on your calculator, you'll see that it's a pretty tiny number, and it keeps on getting tinier. So this thing does not diverge by the nth term test. It might turn out it diverges anyway, like the harmonic series diverges despite approaching 0, but the nth term test can't tell you if something converges, only if it diverges. Then it's up to you to sort of look for, well, hey, if I know it doesn't, if the nth root test doesn't tell me it diverges, is there some way I could see that it maybe converges? All right, why are these two tricky? Well, you notice we have 1 minus n instead of n minus 1. So the funny thing about this exponent is that when you plug in bigger numbers of n, the exponent gets negative. So the first term is going to be 2 to the 0. Then the second term is going to be 2, and we plug in 1 minus 2 is negative 1. And then the third term is going to be 1 minus 3, which is negative 2. So these are actually, this is 1. 2 to the minus 1 is 1/2. 2 to the minus 2 is 1/4. So look at this. This is a tricky way. Even though it looks like the terms will get bigger because we have the number 2 raised to the exponent with an n in it, because there's a negative sign in front of the n, that flips things, and this thing ends up not, it's not diverging. At least it's not diverging by the nth root test. Sorry, nth term. There's something else called the nth root test, which is complicated and useless, that we'll be talking about later, so that's why I keep slipping the tongue on that one. All right, so this one does not diverge by the nth term test. However, this one does. So this is one that sort of looks like it would go 0.1 plus 0.01 plus 0.001. Because we have 0.1 raised to a power with n in it, but once again, this is 1 minus n. So it turns out the actual series is, first we have 0.1 raised to the 1 minus 1, which is 0. Then we have 0.1 raised to the negative 1. Then we have 0.1 raised to the negative 2. So this will be 1. 1 over 0.1. 1 over 0.01. So that's going to be 1 plus 10 plus 100. So it turns out that because the n has a negative sign in front of it, these terms get really big really fast. And this is going to definitely diverge super quick. So the limit on this one, if you're using the nth term test, the limit as n approaches infinity of a sub n is actually infinity. It diverges. All right, hopefully this is seeming tedious. And last one we'll do here. This one looks really funky, like it's not obvious what type of series this is or anything. But turns out this is actually not so bad. It's a geometric series, or it's a hybrid of two geometric series. So what we can do is we can break it up into two fractions. Because we have two things in the numerator separated by a plus sign, we can break this up into two series. One is 2 to the n over 4 to the n. And then the second one is just a 3 to the n over 4 to the n. Oops. That's up there. So this first one, 2/4 is just 1/2 to the n. And this one's 3/4 to the n. So you can see that now if we take the limit of each of these series separately, you can see that they're converging to 0. So this one, 1/2 raised to the infinity power. So if you want to take the limit of, since we're using this particular test, the nth term test, as n approaches infinity, 1/2 to the n, you can see that if you raise 1/2 to a really big power, you get 0. And the same thing for this 3/4 to the n. So if you raise 3/4 to a bigger and bigger power, your terms are also going to approach 0. And that doesn't mean that the series converges even, right? We just know that the series doesn't diverge by the nth term test. Because remember, the nth term test, if these had not been 0, if these had been something else, then we'd say, oh yeah, that thing diverges. Because the nth term test says if the limit is not 0, the thing diverges. But if the limit is 0, it could still diverge. We don't know for sure. Turns out we can kind of figure it out because this is sort of the classic formula for a geometric series, which we'll talk about again in the next video. But so we could figure out the sum of this thing pretty easily, because this one would be, so we already detected that it converges. But if we take 1/2 to the n, so the first term will be 1/2. So if you want to figure out the sum of this sequence, it's just 1/2, right up here. So the sum of that first thing is 1/2 over 1 minus r, so 1 minus 1/2. So that's 1/2 over 1/2, this equals 1. And then the sum of this term is just going to be 3/4 over 1 minus 3/4. That's the sum of a geometric series. 3/4 over 1/4 is 3. And then maybe if we had started over with 0, it would have been bigger. But point is, it looks like this thing, the sum of this entire infinite series is going to be 4, 1 plus 3. But we'll do that in the next video anyway for a geometric series. So the nth term test, the point there is that if the terms are not getting smaller and smaller and smaller as you go to bigger and bigger n's, and they have to be approaching 0, the thing will diverge.